Okay, let's look at this problem here. Show all your work and formulas used. Just write, that's supposed to say write your answer in a complete sentence with appropriate units. Suppose your dog weighed 4.5 pounds at birth and weighed 15 pounds a year later. Based on these two data points, find a linear function that describes how weight varies with age. Use this function to predict your dog's weight at 4 and 15 years. Comment on the validity of this model. So we are asked to do quite a few things. First, we need to find a linear function. We're going to get, we're going to then use that function to predict the dog's weight at 4 and 15 years. And then we're going to comment on the validity of this model. Is the math that we did worth it? So let's start with the linear function. So before we do get going, this is a work with me video. So make sure you have a pencil and paper and a calculator ready to go. I do not recommend using your phone calculator unless you're super comfy with using fractions. I'm going to be using Desmos Scientific Calculator. It will be linked in the description. It's free online or free download, whatever you want. You can use it on your phone, your computer, or pretty much everything. And it's my favorite. So if you want, you can use this follow along with me. If you are comfy using your phone with fractions, go for it. I'm fine with it. But I would recommend you do the math as I do it to make sure that you're getting the correct numbers. I also would recommend that before you dive into this, since we are in chapter 9 of quantitative reasoning, it wouldn't hurt to take a look at the notes we have. So if you look, this is the QR page. This will be linked in the description as well. Always check the description. There'll be goodies down there. And we have a chapters 8, 9, and 10 study guide. And if you open that and get down to whatever page starts number 9, page 5, this goes through the basics of what we're talking about here. 9A and 9B are going to be, I think, what we're predominantly working on. Yeah. So go ahead and do that first. It'll make a lot more sense if you have some idea of what's going on. Like I said, this will be linked in the description, and I will also make sure I link a couple other resources too. Okay. I'm hoping that you've done that. And we can go on. So, based on the two data points, find a linear function that describes how weight varies with age. Now, think about it. In a linear function, there's a dependent variable and an independent variable. The dependent variable is aptly named because it depends on the other thing. For instance, we're talking about, in this example, we're talking about a dog's weight. How much a dog weighs depends on a couple of things, like its breed, but it also depends on how old it is. A puppy will not weigh as much as a 5-year-old dog, right? So the dependent variable in this problem, where's my pen? Right there. Dependent, the weight literally depends on the dog's age, which means the independent variable, that's not how you spell independent. Independent variable would be the dog's age. It's very important to know which one of these is which is dependent and which is independent. Because if you look at the chapter 9 notes that we had pulled up a second ago, which I will do now, when you are talking about forming a linear model, which is what we're going to do, you're going to need what's called the slope or the rate of change. And the rate of change requires you to find the difference in the dependent variable and the independent variable. So that's why we had to first identify which was which. So we have done. We know that the dependent variable is the weight, independent is the age. Let's go and list out what these actual numbers are. And you know what I'm going to do too? If you've had any math experience before, you might have seen graphing. Like this fella here, and you got X, and you got Y, and you got a point or a line, whatever. That's kind of what we're doing here. Actually, that's exactly what we're doing here. So I'm not only going to determine which one is dependent and independent, I'm going to label them as X and Y. The dependent is Y, independent is X. So I'm going to go ahead and say right over here. Sorry. The dependent is right here. That's my independent right there. Okay. And I do have, it says we have 2 data points. We have 2 data points. So we have 2 values for the weight, and we must have 2 values for the age. So let's look at the weight. So the first weight that I see is 4.5 pounds. So that is Y1. 4.5 pounds. There must be another pound value, which is going to be Y sub 2. And I do see another one to say 15 pounds. So that is my second Y value. Now each Y value goes with an X value. So how old? We know that X is the independent, X is also the age. So when the dog was 4.5 pounds, how old was the dog? How many years old was it? Reading the question again, it says, suppose your dog weighed 4.5 pounds at birth. So the moment it popped out, it weighed 4.5 pounds. So it is not any years old yet. It's, I don't know, a millisecond old, but we're just going to, for the sake of this, we're going to say it's 0 years old. So there must be another age value that goes with the 15 pounds. What do they tell us about when the dog weighed 15 pounds? Let's see. Weighed 4.5 pounds at birth, weighed 15 pounds 1 year later. So that means when it's 1 year old, it weighs 15 pounds. So let's go ahead and use the formula for finding the slope to calculate the slope. We're going to find the rate of change here. That is a vital part of finding your linear function. Scroll, scroll, scroll. So the formula for slope, let me know if this rings a bell. M, which stands for slope, for some reason, is the difference in the y components divided by the difference in the x components. Oops, that right there is a 1, not a 2. I apologize. So we have labeled all of our components. Y1, Y sub 2, X sub 1, X sub 2, all that stuff. So I'm just going to plug them in. The first thing I need is to plug in Y sub 2. Our Y sub 2 is 15. I do subtract, and then I plug in Y sub 1. Y sub 1 is 4.5. And that gets divided. And I have to plug in X sub 2, which is 1, and minus X sub 1, which is 0. So we're going to perform this calculation here. We have 15 minus 4.5. Brain math. 15 minus 5, which is 10, plus an extra half. You're totally welcome to use your calculator for that. There's no harm checking. And then 1 minus 0 is just 1. So we have just found the slope, 10.5 over 1. It's a positive number, right? There are no negatives here. Just positive 10.5, positive 1. So in words, the slope. Hang on, I just heard a noise that my cat made and probably shouldn't have made. Yep, hold on. I should pause this, but she's fast. Okay, got her. If you want to know, leave a comment. Back to the problem. The slope is 10.5 over 1, which in words, normal English, means, remember where we got these top numbers? The 10.5 came from subtracting the 15 and the 4.5, and those were pounds. So that means, because it's a positive, the dog increases its weight. And in this case, it gained 10.5 pounds in, see down here, that's how much time has elapsed, 1 year. Probably, if you had been given this information without it being in the format of a math word problem, you probably would have been able to figure that out just instinctively. Oh yeah, my dog was 4.5 pounds and now he's 15 pounds. Wow, he gained 10.5 pounds and it took 1 year to do that. That's basically what we just did. We just made it look fancy. So we have found the slope. The slope is 10.5 over 1, and we can actually simplify that now. Anything divided by 1 is just itself. So for further calculations, we're just going to use 10.5. But we do have it in words. The slope is 10.5 over 1, which means the dog gains 10.5 pounds, pounds in 1 year. All right. That's not what we were asked to do, though, is just to find the slope. We were asked to find a linear function, so we're going to keep going. There are a couple of different ways that you can find a linear function. One of the methods, the one that I know the best, is the point slope form, and we're going to use that for this video. I will link to some others in the description if I can find some good ones. But we're going to use point slope. And this is the format of point slope. Y minus y sub 1 equals m times the difference of x and x sub 1. Now, luckily, we have three things. We have y sub 1, we now have m, and we have x sub 2. I'm sorry, they should both be 1s. I just said that. Anybody offering penmanship classes? I should probably enroll. So what we're going to do in this form is we're going to leave the beginning y exactly the way it is. And we're also going to leave the subtraction exactly the way it is. Everything that I underlined in red, we're going to change with the values that we have. And then everything I didn't underline, we're going to leave alone. So starting off, not over there. Okay. There we go. So y sub 1, we label that up here. Work, technology, please. There we go. Y sub 1, we labeled right here. Y sub 1 is 4.5 pounds. See? Oh, yeah, there we go. So I'm going to plug that in. And while I'm up here, x sub 1 is 0. So let's just remember those two numbers. Hopefully you have this on pen or pencil and paper right in front of you, and your computer is not doing mean things. So y sub 1 is 4.5. M, we just found. That was the slope. Remember the slope formula? Ooh. Right up there. M equals blah, 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 blah. We did all that math. We found it was 10.5 over 1. And I said that for future calculations, I was just going to omit the 1 because dividing by 1 doesn't do anything. So I'm just going to use 10.5. That's how much weight the dog gained in 1 year. Leave the parentheses, leave the x, leave the minus. We'll plug in x sub 1, which we said was 0. You can look back at your notes or scroll back and rewind the video to double check, but we should be good. So this is now the equation in point slope form. Technically, you could leave it here. Nothing wrong with that, except I don't like it, so we're not going to. We're going to isolate y. We're going to solve for y. So first thing I'm going to do, I think, is some distributing. I'm going to take this 10.5 and I'm going to distribute it. 10.5 times x. 10.5x. 10.5 times 0 is 0. Negative, positive doesn't matter, just 0. So I'm going to keep going. To isolate y, I will need to add 4.5 to both sides. This is not 4.5x, so I'm not going to combine any terms. I am going to have to add a new page. Pardon me. And my computer. Okay. I could be like that. No, it's me. It's just me. So we're going to add 4.5 to both sides. Like I said, this is not a like term. We can't actually do 10.5 plus 4.5 because the 10.5 is attached to an x and the 4.5 is not. So we are going to end up with y equals 10.5x. Sorry, the x looks too far away. Y equals 10.5x plus 4.5. Do you have that on your paper? Sincerely hope so, because I do not have it on mine yet. Do I need a new computer? Yeah. Am I going to get one? Yeah. All right, y equals 10.5x plus 4.5. And again, this is something that without the mathy bits, you probably would have instinctively figured out. Essentially, we have said, okay, my dog started at 4.5 pounds when I was born, and then it gained 10.5 pounds for every year. That's this formula here. That's what it's saying in words. So that would be the first part of this question. We were asked to find a linear function. We have it. I will circle it. Now, the next two calculations, I'm going to leave up to you. Can't do it all for you. Where's the fun in that? I'm trying to erase that little. Okay, there we go. So let me circle this because we do now have the linear function. This is an integral part of this problem. And I will get you set up for the next part. The next part requires, and I'll go back and we can reread it. So I've done a lot of talking. Sorry. So let's just suppose your dog weighed 4.5 pounds at birth, then weighed 15 pounds a year later. Based on these two data points, find a linear function that describes how weight varies with age. We have done that. Our linear function is, I'll write it out again, y equals 10.5x plus 4.5. This is our linear function. It says we now need to use this function to predict your dog's weight at 4 and 15 years. So we're going to do two calculations, one for the dog's weight at 4 years and one for the dog's weight at 15 years. So I'm going to do, basically you're just going to plug in the value for x. So instead of 10.5x, you can do 10.5 times 4 plus that 4.5. And this will get you the dog's weight at, or its predicted weight, I should say, at 4 years old. And you'll do the same thing for 15. You will plug in a 15 instead of a 4. And these will get you the predicted weights for the dog at 4 years and 15 years. So make sure that you do label that. There should be, whatever number you get is going to be pounds. Pounds, we're talking about pounds. Okay, so go ahead and do that. Pause. Figure it out. You can throw that into your calculator. Just throw it in with parentheses the way you see it, or multiplication symbol. I don't really care. Your calculator should follow PEMDAS, and this is a relatively simple function, so it should be okay with that. See what you get. Remember, the dog was 15 pounds at 1 year old, and we are assuming the dog is going to continue to gain 10.5 pounds every single year. How big will this dog get according to math? That's what you're going to figure out right now. Feel free to leave a comment with what answers you get, or you can email me if you want to double check your work. I'm not going to put the answers right up here on the screen because that would be cheating. But you can definitely reach out to me with whatever you get, and we can chat about it. So go ahead and do that. I'm going to go to the last part of this problem, which says comment on the validity of this model. So hopefully you have paused me, or you will pause me, and you have some numbers. You have some answers here for how much the dog is predicted to weigh when it's 4 years old, when it's 15 years old. What I need you to do is to think about the numbers you have and think, does that sound right to me? Does that seem reasonable for my dog to weigh that much? Or to weigh that little? I don't know what the numbers are. I haven't done the math. You have, hopefully. And if you're not sure, you can always do a little research. You may be a dog person. You may have dogs. You may know what their weight is. You may know how much weight they gain every year. Just think it through. Does a dog, or does any life form, gain the exact same amount of weight every single year? Just think about that. If the answer is yes, then sure, this is a valid model. If the answer is no, then this would not be a valid model. So just give them some critical thought. Again, feel free to email me or drop a comment if you want to work it through with me. We can totally do that. I will look for another example of this kind of problem if I have one, but I will, and if I find one, I'll leave it in the description. But I will definitely leave a link for the calculator, the chapter 9 notes, and anything else I think might be helpful or useful. Otherwise, that's going to be it for this video. Like I said, definitely feel free to drop a comment or send me an email if you want to talk about the numbers you got and what you think about the validity of the model. Is it a good model? Does it work? Is it accurate? Or is it garbage? Is it not accurate? We can talk about that if you want to. I wish you the best of luck. I'm here if you need me.